Hello everyone, welcome to another video. In this video we are going to discuss ports and adapters architecture, also commonly known as hexagonal architecture. Okay, so the first thing that we need to understand about um, hexagonal architecture and other derivatives like clean architecture is that those architectures, they tend to have a mindset where your business logic, your application is at the center, or at least is what you care the most about. Okay, and so uh, in the case of hexagonal architecture, and also as I said, clean architecture, your goal is to isolate your business logic from external dependencies, because your business logic is, at the end of the day, what makes your application special, is what is the moneymaker. Okay, so you would want to isolate that thing that makes your application special, or your company special, from any external dependencies that might change over time. Okay, as the normal example we give is what happens if you change a database, even though that might be a not so frequent task, I would say. Or what happens if now, instead of using RabbitMQ, I want to use Kafka, or I want to change the email provider I'm using. Okay, how would you do that in a way that your business logic will remain unchanged? Okay, so that this is one of the premises of those architecture or design styles, is how can you isolate um, your business logic from those implementation details. Okay, so this hexagonal architecture came in by Alistair Coburn. I think he started to think about it in early mid 90s, and then officially in his blog in 2005. And the intention, according to him, is to allow the applications or business logic to be equally driven by users, programs, or automated tests. Okay, and to allow this application to be developed and tested in isolation from runtime devices and databases. Okay, generally speaking, these kind of external dependencies. And so this is what these architectures are for, is to give you guidelines or ideas on how you can isolate this. Okay, so the power that you have by following this kind of architectures is, theoretically, you can run your application all in memory, with in-memory dependencies. Let's say, so you can replace your database with an in-memory database. You can replace your email with something to a console log or something like that. So technically, the power that you have with this kind of architectures is that you can replace all of your external dependencies with in-memory. Okay, and this is very useful, especially when you're doing tests. Okay, so this is one of the benefits of having this kind of isolation and treating those external components as something that you can plug and play whatever you want. Okay, you want to use RabbitMQ or Kafka, it should be transparent to the application. The application should not need to understand what kind of delivery mechanism you're using. And so, having that said, we can go to some other details specific to hexagonal architecture. So, history-wise, the reason why it's an hexagon, according to its creator, is that Alistair wanted a shape that was not taken, and then, it was somewhat symmetrical, and the hexagon, was the perfect shape that he found back then, because everything was using squares, and using squares for him, it did not fit what the message he wanted to transmit or to pass along to us. And so the hexagon was the shape that he um, that he used. And so another thing about the hexagon is that it's not at all limiting the number of things you have to have. As an example, soon we will speak about ports. The hexagonal architecture is not telling you that you have to have just 6 ports. The hexagon is just a shape, is just a visual way to represent something or to transmit something. And so there's no actually technical limitation just because it's an hexagon. Okay. And so one of the things that we can now speak about hexagonal architecture is all the components that are related to it. Okay, it's an architecture that, and we will see this when we speak about ports, that is very oriented to the use case. A use case is just an intention. When someone uses our application, they use it with a specific intention, and normally that intention can be translated to a use case. Okay, but let's speak now about the components. Now that we know that hexagonal architecture is about this isolation of your business logic from your external components, like databases or message brokers and so on. So the first component that we need to understand is the famous hexagon, right? So that's the moneymaker, as I told you before. That's where your business logic should be. Okay, and as I told you before, that business logic should be isolated from any external dependencies, any external abstraction that you might use. Should not propagate, should not contaminate your business logic. Okay. Now, one thing you might be wondering is how should I structure my business logic according to this hexagonal architecture? Because when you come from paradigms such as clean architecture, clean architecture is somewhat prescriptive. It gives you some guidelines on how to structure a code, what kind of possible layers you can have. But hexagonal architecture, or ports and adapters architecture, also we can also call this ports and adapters, which is, I believe, the official name. But this hexagonal architecture does not tell you how you should structure your code. It's not prescriptive on that part, and so you can do whatever you want. Okay, you can use clean architecture. You can use and clean architecture, in my perspective, is a derivative from hexagonal architecture, a bit more prescriptive, but it's just my opinion. And so you can do whatever you want. Okay, as long as you isolate your business logic. Okay, that's the entire purpose. Okay. You can organize it the way you want. Okay. Now, in terms of the hexagon, you'll notice that normally when you see diagrams related to this hexagonal architecture, there's always something funny on the left side and something funny on the right side. Okay, so the middle of the hexagon acts like as a boundary. Okay. Oh, this is just a virtual boundary just to represent something, but so normally everything that is on the left side of the hexagon, if you have here like a visual middle line, everything that's on the left side of the hexagon represents interactions with our applications. So people in the general sense can be systems, but it represents interactions with our system, calls to our system. Okay, it can be a user, can be a message broker, can be another system calling a REST API, can be whatever. Okay, but Normally, the left-hand side of the hexagon represents people or things in general that use our application. Okay, and we tend to call this entities that use our application as driving entities or driver entities. Okay, you can see this here by this diagram. Okay, we will go to the components soon, but just to let you know that whenever you see driver or driving or primary, that normally refers to things that are on the left hand side of the hexagon. So things that enable your application, that use your application, okay, that have an intention when using your application. And in contrast, the things that are on the right hand side, as you can see here, we call driven or secondary, are things that our application uses because it needs to do something. As an example, I need to send a notification, I need to send an email, I need to save something on a database. It's something that my application uses directly. And so this normally is on the right hand side of the hexagon. So things that our application uses. So they are normally on the right hand side of the hexagon. Okay, so just to recap what we just saw, so we know that the hexagon is where our business logic is located. We don't care how it's organized. It can be clean architecture, it can be whatever architecture you want, or the software design principle you want. Does not matter as far as hexagonal architecture. Hexagonal architecture is not prescriptive on how you organize your code. Everything that is on the left hand side of the hexagon is things that use our application. So we tend to call these driving or driver or primary. And things that are on the right hand side of the hexagon are things that our application needs to use in order to perform something. Store state, send a notification, whatever. Okay. Though the right hand side, we tend to call it driven or secondary. Okay. Now, we saw that we have our business logic located inside the hexagon, right? Now you may ask yourself, I have this business logic. Now, how can I call this business logic from the outside world? Okay. And how can I enable those things that I just told you about? How can I store state on the database? How can I make sure that people from the outside world can call my application? Okay. And this is where ports come in. Okay. Ports, they are not outside the hexagon, they are in the hexagon. Okay. But ports are just interfaces, contracts that are specified by your hexagon. Okay. Ports that are on the left side are called primary ports or driver ports. Okay, and ports that are used by a user or another system. Okay, so these are interfaces or contracts that allow someone to use our system. Okay, interfaces, not necessarily interface as in an interface in code, but as in a contract, broadly speaking. And you also have interfaces or ports on the right hand side. So these are contracts that our application defines that, okay, I want to store something on the database. This is the contract I use. I want to send a notification. This is the contract I use. I don't care the concrete implementation. I just care that whenever I want to do this operation, this is the contract. Okay. And ports, okay, they can be grouped by intent. Okay, so we can have here a group of ports for persistence. Okay, so these are ports or interfaces or contracts that we specify for persistence, but we can also have ports for notification. Okay, and this is in the case of the driven ports. Okay. Same things for the driver ports or driving ports. Okay. So as I told you before, these ports, even though here on the diagram they are represented as being outside the hexagon, they are actually something that belong to the hexagon. I just put them in outside just to be easier to understand, to explain. But in reality, they belong to the hexagon because the hexagon defines the contracts, defines what it expects. Okay. As I told you before, if the ports are on the left hand side, they can be use cases. Okay. And use cases, they have well-defined input and output. Okay. And so the business logic specifies, hey, if you want to use my tax rate functionality, if you want to compute a tax rate, okay, the use case, okay, the behavior to compute a tax rate, this is what you have to provide to me as an input, and this is what I give you as an output. Okay. So I will create a video about the anatomy of a use case and how you can implement this hexagonal architecture in practice, but the left-hand side ports normally are bound to a use case or an intention in using our system, which we call use cases. Okay. So I told you there's this business logic. Then we have contracts, ports that allow you to use the application or let the application use the outside world. Okay. And now we will take a look at adapters and how they are the mechanism that allows us to actually make use of the ports. Okay. Because the thing with ports is that this is an interesting thing in my opinion, is ports, they are used because you can plug and play whatever you want. Okay, for example, the persistence port, you can plug in a database, you can plug in a in-memory database or whatever you want. Okay, so you can swap whatever is here. Okay, and so that's the beauty of having this isolation, is that you can plug and play whatever you want here on the right hand side as well as on the left hand side. Nothing changes here, and people can still use your application, and you can use other dependencies without having to worry too much about external details. Okay. So ports are the contracts. Okay. So if you want to use my restaurant, this is the behavior you should have, and this is what I give you. So if I go to a Japanese restaurant, I know that I will have Japanese food. If I go to a Chinese restaurant, Chinese food, and so on. So it's a contract. Now, the adapter is the middleman between actors. We haven't seen actors, but we will see in a second, and ports. Okay. What adapters do, they are coupled to a specific actor, and they translate whatever language the actor uses into language that the use case understands. Okay. So as an example, let's assume that this is an HTTP adapter and that the user sends a CSV file with a list of, I don't know, PDF file names. But our use case does not accept a CSV file. It accepts a string array. So this adapter would take this input from the user, convert it to a language that our use case understands. Okay. So just as an example, so this adapter acts as the middleman between actors and ports. They are coupled to a specific user or actor. In this case, can be a controller or something that is bound to HTTP requests. So they take the information from actors and then translate it to a language that the use case can speak. Okay, another example can be you receive from from the front end, assuming that this is a front end enabled application, you receive an array of strings, and those strings are numbers, and then your use case just accepts an array of ints. And so you have to do this adaptation between the outside world language and what your use case specifically accepts. Okay, so it's like an intermediary layer, if you will. So we know that adapters, they are this middleman that uses our application, and of course we also have them on the right hand side. Okay, so on the left hand side, the adapters, they use our ports, they use our use cases, but if they are on the right hand side, it's a bit different. So the business logic, the Hexagon, defines the ports for persistence. Okay, you can think of this broadly speaking like you specify your iRepository interface. Okay, it's not very much that, but imagine you specify the iRepository interface here, and your application uses this generic repository to save data. And then you have your adapter, your MongoDB repository, for example, that implements this interface is specified by this port. Okay. Of course, on the left-hand side, we specify the port contract, and of course, we have something here on the business logic that implements this use case, of course. But in this case, what implements the persistence port is not the Hexagon itself, but the external dependency. Okay. In this case, the adapter. Okay. Same here for the notification. You can specify an iNotification and then somehow inject if it's an email or if it's a RabbitMQ one. Okay, so the important bit is the contracts. Okay, and in the left hand side, the adapters use this contract. Okay, and in this case, they implement the contracts, and then you just use the ports, the contracts you specified. Okay. Now, speaking of actors, on the left-hand side are the actors that actually use your application. They have an intention on using your application. We call them the driving actors, or driver, or primary actors, as we saw previously. Okay, they have an intention to use your application. As an example, you can have some web portal that a user performs administrative tasks. And then this user uses a specific front end. That front end does API calls to your API adapter. It can be a controller, whatever you want. And then this controller takes this input and then translates it to a language that the use case can use, that your Hexagon can use. Okay. And on the right hand side, we have the actors that are used by our application, that our application enables. We call them driver or secondary driven or secondary actors. Okay. And as I told you, our application uses them. We don't use them directly, we use them indirectly. Okay, the adapter here has a critical role. But yeah, that's pretty much it about the overall components. The Hexagonal architecture is actually a simple architecture. Okay, it doesn't have much about it because it's only here to help you with one or two software design decisions. Okay, this isolation and have these middlemen and so on. So it's a very simple architecture. And in my perspective, as I told you, for me it's the cornerstone for things like clean architecture. Because if I rephrase this a bit, you can see all of the clean architecture here somewhere. So yeah, I mean, for me it's very interesting kind of architecture. Okay, it's simple but yet effective if you do it well. And so stay tuned. I'll soon release a video where we implement this in detail, and hopefully I see you there. Thank you so much.